ask you a question, you are able to throw it at me. So it's a very it's a concept that was repeated over and over, but it's still good all the same. You get. So today we'll be dealing with object-oriented programming, understanding the four pillars of OOP. You get. There are four pillars. There are not three. There are four. So and our instructor, our somebody that will be blessing our knowledge, giving us a lightning sharp knowledge, Mr. Adeleke. So without Adeleke is let me tell you guys a little bit about Adeleke. Okay, let me tell us a little bit about Adeleke. Adeleke is a Java guru. That's the little bit, and it's very very powerful. So without wasting much of our time, Mr. Adeleke, you have the floor. None of you are even clapping for Mr. Adeleke. It's fine. Okay. Yeah, Adeleke, you have the floor. Let me. Okay.
All right. Good evening, Samuel. Good evening, everyone. Please confirm if you can hear me.
Yes, I can.
Yes, I can hear you. Is the screen audible? So I
Yeah,
say
yeah,
the
yeah.
screen audible. Sorry.
It is visible. Mr. Samuel, you need vacation. Seriously, you need to go cool yourself. All right. So, good day, everyone. Right. Apologies, I couldn't do the laptop to do some practical. Mr. Samuel and the other admins, right, we can move
Sorry,
on.
you are not coming out. You are not coming out properly.
How about now?
Yes,
Can you
yes,
hear me
now it's
clearly?
good. Yes, now it's good.
All right. Please, at any point when you stop hearing, please just call my attention to it so that I can adjust. All right. Like I was saying, I said I hope Mr. Samuel and the other admins could give me a second chance whereby I can come and would make it towards more interactive, more practical based. Right. So without further ado, let's get into our item today. All right. So just like Mr. Samuel said, my name is Adeleke Abdurraqib. I am a software engineer and currently I'm enrolled at JUG Bootcamp. Right. Okay. So today's topic is on object-oriented programming. I know we all know object-oriented programming, right? It's a paradigm, is a design structure for programming, and there are other various structures. There's procedural, there's functional, right? But we will be based and focused on object-oriented programming. And what are the four pillars of OOP, right? This object-oriented programming is something that I'm sure everybody here is used to, but sometimes revisiting concepts and understanding what you use makes you a better developer, a better software programmer. Right. So without further ado, let's get into it. Yeah, next please, Mr. Sam. All right. For introduction to object-oriented programming, what's object-oriented programming? Right. Object-oriented programming is a programming paradigm based on the concept of objects which can contain data that is represented in the form of fields, often called attributes or properties, right? Also known as variables and logic. And hello, can you still hear me? Hello, can
Yes,
anyone
we
hear
can
me?
hear you. We can hear you. We can hear you.
Yes, we can.
I don't know, Mr. All right. Mr. Sam, you're breaking, so I don't know if it's
Oh, oh,
network from
oh.
my side or from yours.
Sorry. We can hear you. Now.
Okay. All right. So Please, at any point, just call my attention should in case there's a bit of. All right, so we said object-oriented programming is a programming paradigm based on the concept of objects, which can contain data that is represented in the form of fields called and often called attributes or properties, and logic, which is also represented in the form of procedures known as methods. Right now, so object-oriented programming wants you to think about programming as a list of instructions, right? Instead of thinking about it as a list of instructions, OOP encourages you to think about them as a collection of interacting entities. Now, next slide, please. So there is no way you talk about object-oriented programming without talking about what a class is and an object, right? So what is a class? What's the concept of a class? So basically, a class is a blueprint or template used to create objects. It defines the properties and behaviors that the objects created from it will have. What are the key features of a class? A class contains the variables or attributes. This describes the characteristics of the class and the procedures, which is the methods. It defines what the object does, right? So if you look at the slide, Mr. Sam, next, right? If you look at the slide, you would see a snippet, right? A code snippet. This is an example of.
Sorry, Adeleke,
I'm sorry.
hello,
Yeah, I can hear you now.
hello.
Hello, I can hear you, Mr. Sam. Hello, can anyone else hear me? I think Mr. Sam's network is a bit shaky. Can anyone hear me?
Yes, I can.
Yes, we can hear you.
Mr. Sam, I think the network is from your hand.
Wait to join.
All right, all right.
Hello.
Hello, yeah, we can.
Yes, I said that the page you are currently on.
Yeah, the next page, please. The one with the code snippet.
Okay.
All right. Okay, so this is basically the snippet of how a class looks like in Java, right? You see, we have the class name. This is a race car, right? So I'm a fan of motorsports, right? So I use the race cars as my illustration, right? So for those of you also that they are into cars, maybe you understand this a bit better, right? So we said a class has attributes, right? The attributes are also known as fields, right? We have the manufacturer, we have the model, and the category of race which the race car is in, and it also has a method which is the start engine methods. This basically just prints out the category of the race, the manufacturer, and engine rolls to life. Right, so this is basically a class. Class is structured with just logics that for those that are not into programming, it might not make sense for now, right? But when we get to object, it will become a bit clearer. All right, so next slide, please. All right, so now what's an object, Mr. Sam? Mr. Sam. All right. So what's an object? So we say an object is an instance of a class, right? It is the actual entity created using the class blueprints. So how do we create a class, right? Still using our risk analogy. From the snippet, you could see we created a class, the objects of the class race car in a Le Mans race class. This Le Mans race is basically a race, right? Is a race. I don't know, for those that are into motorsports, they know the Le Mans series is a race series, a 24-hour series, right? Now we create objects of the car class, two objects of the race car class objects. We have car one and we have car two. So for car one, we assign values, right, to the attributes, to the fields. Say the car one manufacturer is BMW. Car one model is M4 GT3, and the race category is a GT race racing. And for the second object, the car manufacturer is a Porsche. The model is 911 GT3R, and for the category is also a GT3 category. And as you can see, we also called the logic which was in the race car, which is the start engine. And if we should print this out, for car one, basically prints the GT3 BMW M4 GT Evo rolls to life. And for the car two, same thing. It prints out the GT3 Porsche 911 rolls to life. Right, so this is how an object is created in. This is using a Java. Right? Basically, we have other programming languages which also uses the OOP design structures. We have likes of C++, we have Python, but for today's illustration, I would basically focus on Java, right? So after being aware of what a class is and what's an object, then we'll dive into the pillars of the OOP. Mr. Sam, next slide, please. All right. So what are the four pillars of OOP? These are also called the principles of OOP, right? What governs the whole OOP design, the whole structure, the whole paradigm, right? We say there are four pillars of OOP. We have encapsulation, we have inheritance, we have abstraction, and finally we have polymorphism, right? So let's see how this helps us to structure our codes. All right, next slide, please. All right, so encapsulation. Generic meaning of encapsulation, when you see something encapsulated, it means when something is enclosed, like it is hidden. It is hidden. A real world example would be applications, right? We have these. Basically, what that means is substance inside the chemicals of the thin coats with a real life. Hmm. Like encapsulation object oriented programming, very good, and the code that acts on that data. Like
Adeleke,
if
you're
you
no
think
longer
of,
audible.
yeah. Oh, all right. Let me come again. I said, can you hear me now? Is it clear?
Yeah.
Am I clear?
Yes, we can hear you now.
I said encapsulation is one of the four fundamental principles of object-oriented programming, right? It is the technique of wrapping data or variables, attributes, and the code that the methods together as a. You should think of encapsulation prevents the data from outside the shield. Now, how does encapsulation works? Mr. Sam, next slide. So encapsulation, it works by wrapping data and methods into a single unit, which is restricts direct access to the data, and it improves security and control, right? And encapsulation is achieved by using the keyword private, and we use the getters and setters method to modify this for modification. So without the getters and setters method, there is no direct link of isolated data. I hope I'm still audible. I hope I'm still audible.
Your network is really
We
bad.
can hear you a bit,
Yeah,
but
but
please
we can hear
make
you.
your voice come up. The network, although it's general, though, but please, let's hear your voice come up.
All right, can you give me Mr. Sam? Can you come and give Mr. Sam?
No, please, speak up, speak up. That's okay.
Okay. All right. So this is also a snippet for encapsulation, right? So for the pillars of OOP, we'll be using a virtual zoo as 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 our analogy to what to describe what object oriented the pillars of object oriented programming class called an class have attributes. We have the name and the energy level of the animals, right? So as you can see, it is what it is. The fields, rather the attributes, are what are preceded by the keyword private. Now, from our previous explanation, we said encapsulation is what is achieved by using the keyword private, right? So we also have the get name method. We also have the get name method, and we have a method which is food, right? Now you can see for the get name method, the private name, our once the encapsulated variable objects that are created from the animal class, right, can be our encapsulated variable using the get name method.
Hello. So your voice
Yeah,
has gone again. Hello?
a minute. Let me switch my internet
Okay,
connection.
okay.
Just give me a
Please.
minute, please. Yeah.
Sorry, apologies for the disconnection. I think this Nigerian network issue. We need to do something about it. Like as a developer, we need to do something about it. Okay, Adeleke, are you back?
Yeah. Please confirm you can hear me.
Okay, now we can hear you. Continue.
All right. Okay. I hope the network doesn't break anymore. Right. So I was talking about encapsulation, right? I said encapsulation bundles data and method into a single unit, right, which is a class, restricting direct access to some components, promoting data security and controlled interaction. It enables data hiding to prevent un, unintended modification and enhance modularity. Right now, so in Java, right, Java uses four level of modifiers to enforce encapsulation. Right, we have the private keyword. Right, this makes the data only visible to the class which the data is instantiated. we have the default, right? This gives visibility to the of the data to the entire package in which the class is what is created. We have the protected. The protected, right? It makes these fields or attributes visible to the package and the subclass. Subclass, when we get to inheritance, we'll discuss more subclass, but subclass just basically means a class that extends another class, right? And finally, we have the public keyword. This public keyword gives visibility to the entire code base, allows the entire code base to have access to these attributes, right? Now, next slide, please. Next slide. Next slide, please. Okay, so let's talk about inheritance, right? We'll come back to encapsulation and try to fuse all these four principles into one. But for now, let's just take it bit by bit. Now, what's inheritance, right? In our layman's understanding, or we are looking at a biological understanding, right? We say inheritance. This is the acquisition of traits, right, or characters from parents to offspring. So or you can also say when there is inheritance, right? Well, in our generic meaning, inheritance meaning what? Getting something from one's generation, might be your father, your mentor, right? But just acquiring something from them. Now, if we should use this our knowledge, right, and what's related to Java, we said in Java, inheritance, right, allows one class to acquire the properties and methods of another class. Right? The class which provides the property or the superclass, and the class that's and the class and while the class that inherits them is called the child or subclass, right? Just like I used the biology analogy, right? We said the child acquires and inherits traits. These are characters from the parents. So same thing with Java. The class which is giving out these attributes and methods are called the parent class or the superclass, while the class inheriting it are called the subclass or the child class. Now, um, inheritance, right? It promotes code reuse and logical hierarchy between classes. And to inherit in Java, we use the keyword extend, right? The child class or the subclass extends the superclass or the parent class. Don't worry, we'll see a visual representation of inheritance, right? Okay, Mr. Sam, next slide, please. Okay, so what do inheritance, right? Why do we use inheritance? So what do we get from using inheritance? Inheritance allows a class to inherit properties from another class, right? This inheritance also promotes code reuse and reduce duplication. So just to avoid rewriting the codes, right, which makes one's code base very bulky, and the processing time, what it adds to the processing time. And we know as software engineers, right, the time which our code runs really matters a lot. So inheritance helps us to reduce the workload and what make our code base very neat and easy to understand by other programmers. Okay, so what are the types of inheritance? We have in Java, we have 5 types of inheritance. We have the single inheritance, we have the multiple inheritance, we have the multi-level inheritance, we have the hierarchical inheritance, and the hybrid inheritance. Okay, Mr. Sam, next slide, please. All right, so this is a diagram, right, which shows the 5 types of inheritance and how they are inherited. So let's talk about the first type of inheritance, which is the the single inheritance. The single inheritance, from the word single, is basically a parent to a child inheritance, right? Just like in the real world scenario, once a parent and they give birth to just a child, right? When it's time for inheritance, nobody fights with the child, right, for property. What is hello? Someone speaking. Someone
No.
speaking. Okay. Okay. All right. So, like I said, the parent to child, the single inheritance is a parent to child inheritance, whereby a class or inherit the subclass inherits from a superclass or the parent class, which is this type of inheritance is very straightforward, very straightforward and easy. Right now, we have multiple inheritance. For multiple inheritance, this is where a subclass, one class, inherits from two parents inherit from two parents. Now, in Java, a class can only extend one class. A class only extends one class. So the only way multiple inheritance is possible is through the use of interfaces. What are interfaces? Interfaces are also a form of a class in Java, but this interface what allows us to achieve complete abstraction, right? So when we get to abstraction, we'll understand more on interfaces, right? So the only way in Java where multiple inheritance can be achieved is through the use of interfaces. All right. So we have the multi-level inheritance. This multi-level inheritance is when there is hierarchical, right? The grandparent, the parents, then the child. The parent inherits traits and attributes from the grandparents, and same thing, the child inherits those same those same um those same methods from both the parents class and the grandparents class, which I believe is self-explanatory and straightforward. Right now, for the hierarchical class, this is when multiple classes inherit from one class. So using my analogy of a parent and one child, when the parents they give birth to 3 to 4 children, what happens? All these four children they all inherit attributes from their parents, right? They all inherit equally. So, and for the hybrid class, this is where each class, right, directly or indirectly inherits an attribute from themselves. Right? Example, we have four classes. We have class A, class B, class C, and class D. From the diagram, you can see class B inherits from class A, class D inherits from class B, class C inherits from class D, and class A inherits from class C. So you can see how the inheritance just keeps going in a cyclic format. This is what is meant by hybrid inheritance, whereby these classes inherit from each other. All right, Mr. Sam, next slide, please. Okay, so this is still using our virtual zoo as an analogy, right? This animal class is the parent class, and you can see we have a lion class which extends the animal class. So the lion class inherits an animal class using the keyword extends. The unique thing about the lion class is without needing to implement all the attributes and methods from the animal class, which is the parent class, the lion class is able to call and use these methods. Now, let's take a look. You can see in the animal class, we have a method called sleep, right? Without needing to implement this sleep method in the lion class, the lion is able to call and use the method sleep. Same thing with the string name, right? Although it is encapsulated, but with the help of the getters and setters method, right, the lion class is able to see and modify this type of variable. All right, and you can also see in the the lion class also has a method which is unique to just the lion class. Now, the parent class have no access to this method called hunt. Only the lion class is able to use the hunt method. All right, next slide, please. Okay, yeah. So this is also right. This is also the hierarchy of inheritance using a virtual zoo. Right, I am unable to pack up all these code snippets in my presentation, so I will just be using this diagram to make it what more explanatory, a bit more explanatory. Right, so you can see we have the animal class, right, in this case, which is our parent class. Yeah, and we have two classes, two children class inheriting from the animal class. We have the class mammal and the class bird. Right, you can see the mammal class and the bird class. They both have the ability to use the methods of the animal class, which is the sleep and the eat method, and they also have access to what the attributes, which is the name and the age of the animal class. Right. However, these classes also have methods which are unique to them. For the mammal, we have the walk, and for the birds, we have the flies. Right. Although birds can walk, but for my analogy, right, let's just keep it this simple: birds fly and mammals walk. Now we also see that this is a molecular level inheritance. We also have other classes which inherit from both the mammal and the bird class, and this is how the inheritance keeps going all the way to get to the zookeeper, right? Which the zookeeper, you can see the zookeeper also inherits from a lot of these classes. And this is just a breakdown of how inheritance work using our virtual zoo as an analogy, right? All right, next slide, please. Now let's talk about abstraction. Abstraction, from the word abstraction, abstraction means what? Being separate, being hidden. It's not showing, just it is there, but it is what? It is separate. It is in a part of its own, right? So you say abstraction. This is the hiding. Uh, this can you see the slide? Okay, okay. Abstraction. This is the hiding of implementation details, right? Only showing abstraction only shows when the features are essential. Only shows when the features are essential, and we achieve abstraction either by using an abstract class or an interface, right? So remember when I was talking about multi-level of when I was talking about multiple inheritance, I said multiple inheritance is only achieved using interfaces, right? So now let's say the difference between an abstract class and an interface, right? So what's an abstract class? An abstract class is a class that cannot be instantiated. You cannot create, and this means you can't create the object of the class. And this abstract class other classes. It is designed to be extended by other classes. So an abstract class acts as a base or blueprint for subclasses, right? So abstract class are used when we want to define common behaviors for related classes, but leave some methods for subclasses to implement. Now, so for abstract class have in an abstract class we can initialize attributes. Also, we can initialize attributes, right, and methods. And an abstract class is able to contain abstract methods and non-abstract methods. Okay, and for the abstract methods, a class extending an abstract class must implement the abstract methods, while for the non-abstract methods and for the non-abstract field it is left optional, right? If there is need for the subclass to use these methods, it will use it. Otherwise it is just there sitting and resting in our code base. Now next slide, please. Okay, so using our animal class, right, we can see we've changed the animal class from a normal class to an abstract class. We have the public abstract animal class. Now this is how to declare an abstract class in Java. Now we have an encapsulated attribute, which is the name. We have the constructor, and we have a we have an abstract method, which is make sound. Now this abstract method, any class implementing, rather any class extending the animal class would have to give its own implementation of this abstract method make sound, right? Okay, so what about interface? What about interface? Next slide, please, Mr. Sam. What about interface? What's the difference between an abstract class and an interface? Seems to say both are used to achieve abstraction. Now, an an interface is a blueprint of a class that defines a set of methods that other classes must implement. Now, you can see if you take cognizance of the word must implement, right? Why when I was explaining an abstract class, I said they can, right? If they need to use the non-abstract methods, they can. Otherwise, it is just the dormant, right? But for an interface, it's a must. So all the methods in an interface is an abstract method by default. So any class which is inheriting an interface, and in Java we inherit an interface using the keyword implement rather than extends, which is used for other classes. So in Java we use implement. So any class which is implementing an interface would have to give its own implementation of all the methods in an interface, right? So we say it is used to achieve abstraction, right? Full abstraction, complete abstraction, and multiple inheritance in Java. So unlike regular classes, interface is used to achieve multiple inheritance, right? So we say unlike regular classes, interfaces mainly contains methods declaration without implementation. And any class that implements the interface must provide the method body. Now, let's look at a snippet of how um, the interface. Okay, before then, Mr. Sam, next slide, please. Before then, let's show a diagram of how multiple implementation can be achieved using using interface, right? While still keeping our virtual zoo as our sample. Okay, so we can see from this diagram we have three different interfaces. We have diagonizable, we have carryable, and we have trainable. Right? These are three interfaces. For diagonizable, we have the method, an abstract method, diagonized animal. We have for carryable, we have an abstract method, feed animal. Right? And for the trainable interface, we have the abstract method, train animal. Keep in mind, I use the word abstract method because all methods declared in an interface must be what must they are all abstract by default, and whichever class is implementing this interface must give its own implementation of these methods. Now, for a zoo, obviously we need a zoo veterinarian, right? This zoo veterinarian now implements the three interfaces, the diagnosable, carryable, and the trainable, right? So a zookeeper is able to diagnose an animal. The zookeeper is also able to feed an animal, right, as well as train an animal. So this is how multiple inheritance is possible in Java, right? Next slide, please. Okay, so now let's talk about the last and the final pillar of OOP, which is polymorphism, right? So with our understanding, what does polymorphism mean? Poly means multiple, right, or many, and morphism means form. So basically, we can say polymorphism means many forms, right? Now, what does polymorphism allow us to do? Why do we need multiple forms in programming, right? So polymorphism allows method to behave differently. Basically what polymorphism does is we can have multiple forms of methods, right? Now we have two types of polymorphism. We have the method overriding and method overloading and the method overriding. So let's see briefly. Let's talk about these two types of polymorphism. Next slide, please. Method overriding. What's method overriding? We said method overloading. Method overloading is a feature that allows a class to have multiple methods, with the same name but different parameters. Right, the different parameters. It has to be different types, different numbers or orders of parameters. Right. So polymorphism is a form of compile time method overloading. Rather, is a form of compile time polymorphism because this method, the method that will run is determined during compilation. Right. So I think using a reward analogy would be better. Right. So remember we said method overloading will have the same name, yes, but different parameters. Right. Now let's take the power button of our phone as an example. Right. It's a power button. Right. The name is power button, but our power button can perform multiple functions. Right. To switch on our phones, we press and hold. Right. This is a form of a parameter, is an argument that is passed. Right. You press and hold for for a certain duration. Right. We also use this power button, right, for iPhone users. While the phone is on, if you press and hold, you see it's the function is different. This prompts Siri to come out, right? And this is another different parameter being passed using that same power button. Now we can also use one click of the power button, right? When the phone is on, what happens? It switches off the screen and switches it back on, right? So you can see it has one name, which is the power button, but passing in different parameters, passing in different arguments, right? Holding it for 3 seconds, holding it for 1 second, just a tap, no tap at all of this, right? It prompts different functionality. So this is like a reward representation or a physical presentation of method overloading. All right. Next slide, please. Okay. So can you still hear me? Let me confirm. Let me confirm you can still hear me, please. Okay. Mr. Sam, next slide.
Next slide. That's the next slide now. Can you see my screen?
Yeah. It's still on polymorphism. I don't know if it's my network.
Okay. I don't know. Is this
No.
what you want?
Next, please. Next. Yeah. The one with the code snippets. All right. Yes. So this is a code snippet, still using our virtual zoo as the the sample, right? We can see we have a lion class, right? This lion class extends the animal class. Now, for the lion class, we have a method called feed. We have a method called feed. The first method called feed. This basically takes in no argument. This is a parameterless method, right? Which basically prints the lion ate its standard meat portion, right? We also have another method called feed, still keeping the return type the same, which is void, which this method does not return anything, right? The return type is void. We still have a method called feed. This method, as you can see, it has a different parameter. It takes in a string food type as a parameter, while the first method feed takes in no argument method. Now you can see the implementation of this method is a bit different from the first one. Now this method prints the lion happily ate the food type, right? Say we give you the lion grass, because in our Nigeria now, nothing will no fit happen. Like, right, lion you can just see a lion that is carnivorous, and today tomorrow you hear this lion has started eating grass, or something like that, right? It's just an analogy. Now you can see we also have another method named feed, but this time the method takes in two parameters. We have an integer variable and a string variable, and the implementation, right, what this method returns is a bit different from the other two, right? It returns the lion gorges on the amount in pounds, right? The weights in pounds, and the type of food. So this is a code representation of method overloading, right? Next slide, please. All right. So the second type of polymorphism, right? Is the method overriding, right? For overriding from, I'm sorry, am I still audible?
Yeah,
Yes, we
we
can
can
still
hear
hear
you.
you.
You can continue.
Okay. All right. So method overriding, this occurs when a subclass provides a specific implementation of a method that is already defined in its superclass, right? So for any child class which is what, which is extending or implementing another class, right? Like I said, this class is a subclass or a child class extending a superclass, right? Has the ability to use that method, and it also with polymorphism, this child class also has the ability to what, to configure, to restructure this method to its own, right? But note, the method in the child class must have the same name, the same parameters, and the same return type as the method in the parent class, right? So method overriding is used to achieve runtime polymorphism, right? So okay, I I omitted compile time polymorphism. So what's compile time polymorphism? Compile time polymorphism, right? This basically means your JVM, right? Your JVM determines what method to use during compile time, right? And we know what compilation is. So this is when your JVM is trying to change or to convert your code from words into language which the computer understands, which is the byte code, right? So that's for compile time polymorphism. JVM, it's it chooses the method that will be used. But for method overriding, the JVM, it's a runtime polymorphism, meaning it's at runtime that the method is choosing. Since the method has same name, same return type, and same parameters, right? Obviously, while during compilation, it still compiles it as same. However, during runtime, this is when it is separate. This is when the JVM chooses um, the the method to use. Right now, a real world example of method overriding. Right, it's our 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 TV remote. Right, we have one button, the power button. Right, one tap turns on your TV, another tap turns it off. Right, you see, same parameters. We are giving it just a tap, and it's having its own separate implementation, same parameter, different different implementation, but same parameter, same return type. It's either it owns the TV, or it shuts it off, or it shuts it down. Right. Okay. So next slide, please. All right. So now for the snippet of our of the method overriding. Yeah, still using our virtual zoo. We have the lion class, which extends the animal class, right? You can see, if you remember from our animal class, we had a method called make sound, right? From We had a method called make sound, and you can see at the top of the method, the make sound method, there's an annotation. There's an override annotation at the top, right? This is to tell JVM, right, that what we are doing here is method overriding. And you can see, so for our animal class, the make sound method, okay, sorry, for the lion class, the make sound method prints raw, right? The lion roars, animals, different animals make different sound, right? We also have a bird class. The bird class also is also overriding the make sound method, right? And the bird sound tree trip, right? We can have a goat bleeds. We have what other animals? We have chickens, right? Chickens they crawl, and so on and so forth, right? So each class extending the superclass is what is able to change the implementation of the method while still keeping the return type and the parameters same, right? So this is a runtime polymorphism, right? The method overriding is a runtime polymorphism, right? Next slide, please. Okay, so in conclusion, right? In conclusion, object-oriented programming provides a powerful approach to designing and building software by adding programs around classes and objects. The four pillars of OOP forms the foundation of this paradigm. It forms the foundation of the design of the OOP, right? And what are these pillars? Right, we have encapsulation. Encapsulation protects data and control access to it. We have inheritance. This promotes code reuse by allowing new classes to build upon existing ones, right? Without making our source code bulky and laggy, right? We have abstraction. Abstraction simplifies complex system by hiding unnecessary implementation details. And finally, we have the polymorphism. This enables flexibility, allowing methods to perform different behaviors. All right. So thank you for listening, right? And I await your question. Thank you.
Thank you very much, Mr. Adeleke, for reminding us again why we do what we do. Yeah, object-oriented programming. There are other programming languages, but yet we choose Java. And one of the Java key selling points is object-oriented programming and the fact that it is run once, run once, run everywhere.
Right once, then
Write once, run everywhere. Yeah, that's the two selling point.
yeah,
I get. So, any
yeah,
question? Any question?
yeah. Mr.
Okay,
Sam, you can just take it to the next slide, the last slide.
okay. Uh,
Yeah.
any question? Okay, that's good. Thank you. Any question? Okay, good. Since there's no question, me, I have a question. But not for you, Mr. Adeleke. Anybody that gets this particular question, I'll not transfer 1,000 naira for it. Anybody that gets this question will give the person a coupon, an intelligent coupon.
Oh wow.
Oh yeah, let me ask my question. Now we just discussed the four concepts of productivity. Which of this particular concept is affected in the case of diamond problem? Yeah, I think it's called diamond problem. Diamond, say the death diamond. Yes, the death diamond. Which of these particular which of these particular principles actually affected by the death diamond? Hmm, that's all. Okay, I think I'll keep my coupon to myself. Okay, thank you all very much for attending to this session. We'll meet again next week. Next week will be a very powerful one. Um we're having an external guest speaker, so you guys should watch out. And a very passionate one at that, very passionate Java developer. Yeah, I want to hear from her and learn, and grow. Thank you very much once again for your attention this evening. Have a lovely night.
Sorry, I can see Okeke on the call and Adeleke Farida. So I feel you guys are new here. So please, if you don't join the community, you can just check in the chat before you leave. All our social media handles are there. You can as well join the community. Thank you very much, Adeleke. I'll be in your inbox very soon. Do have a lovely night ahead.
All right. Thank you. Thank you.